functions we've been talking about are relations or relationships between points where you take an input value and you create an output value by following some kind of rule. What is that set of inputs called again? Remember? Domain. So the set of inputs is called our domain of the function. And those inputs give us outputs called what? The range. Okay. So in our class, we're going to use two different kinds of notation. Notation meaning how you write domain and range. The first one is called interval notation. So I'll give you an example, and then I'll see if anybody's seen it before. Interval notation would be something like this. Parenthesis 2, comma, infinity with a parenthesis. Yes, you've seen that. Okay, another example of this could be something like bracket -5, comma, 4, bracket. Okay, something like that is called interval notation. We will talk in a couple of minutes about, if you haven't seen that before, where you use the brackets and where you use the parentheses and things like that. The other notation is called set builder notation. So I know I'm bringing up geometry again, but do you remember when you did probability? When you had sets for probability, what you put around the sets to show you that it was a set? No? The squiggly things, the squiggly brackets. So your set builder notation it's going to be different. That's the only geometry reference for the day. Okay? Your set builder notation starts with the curly bracket. Now, if you're doing domains deal with the x's or the y's? Which one? The x's. Domain is your x's. So you would put an x. You'd say, okay, all the x's. Then you put a line, a bar. That bar means such that. That's a math sentence right there. All the x's such that. Just why? Because it's math. It's a foreign language. You can write whole sentences in math without using a word. You can just use symbols. There's symbols for and, that's and, or you can't even do that. That's and, that's or. Yeah, you can write all kinds. Therefore, oh no, this is therefore. If and only if. You can literally write sentences without words in math. Right? I just wrote you a bunch of words. Alright, no, you would write this x, that means x's in the set such that, then normally there's an inequality after, so it'd be something like -3 is less than x is less than or equal to 4. Something like that would be set builder notation. I know it looks funky. Only a little bit. Don't worry. Don't worry. We're going to mostly use interval notation. And again, this is not exclusive. Interval notation generally is easier to do from a graph. This set notation we're going to look at a little bit today, but we're going to see the set notation more tomorrow when we look at domain and range with equations. Okay? But in general, those are the two different ways you can write domain and range. We will spend a lot of time with them. So let's start with a non-math example. All right? No math involved. So, for example, example 1. Consider the function where its inputs are the months of the year, and the outputs, so let me highlight those separately. The inputs are the months of the year, and the outputs are the number of days in every month. Okay? So we're going to first write a set for the function's domain. The domain is the inputs, right? So we said our inputs here are the months of the year. Well, what months are in the year? You can abbreviate them all. January, February, yes. So list them all. You can even use the first letter if you want to. March. I'll start abbreviating them here. April, May. We're in September, October, November, December. Yeah, that makes sense. Yeah. All right, so that's the shorthand way. But for your inputs, this is our set of our domain. Curly brackets means a set. All those months there are the inputs of the function. Now the output of this function, it says, are the number of days in every month. Now when you write a set, how many days could be in a month? 31. Okay, what else? 30, 28, and in leap years, 29. Do I need to list all the months that do 31? Do you guys know the rhyme? 30 days have September, April, June, and November? No? How come nobody's learned that? No one's teaching anyone. Nobody knows that anymore. It's 30 days have September, April, June, and November. All the rest is 31? Except February. February's special. But do I need to list all the 31? Or all 32s? No, I don't have to list all of them. I just have to say these are the only outputs that I can have. So if I pick one of these values from my domain, 1 month, I have to get one of these days of the month in my range. And that's what the sets represent. So now that we're done non-math, let's think about a graph. We're only going to do graphs today. We're not going to do equations. Only graphs. So we had a graph here. Notice, are there arrows or endpoints on the end? Endpoints. Endpoints. All right, so we're not dealing with arrows yet. We'll get to the arrows in a few minutes. But I'm going to just darken them, but you can see them on your paper. We have endpoints on this graph. The first question says, determine the maximum or the minimum and maximum x values on this graph. Now, I'm going to draw a picture on here. You can draw on your paper if you want, or you can just watch. But it says the minimum x value. Now, are the x's left and right or up and down? Left and right. So at this leftmost point, I'm going to draw a line, just so we can visualize it. And then the maximum x is going to be at that other yellow line. What x value is the maximum one here? We do max first here. How many x's over did you go? 6. So our maximum x value is 6. And where's our minimum x value? -3. Now we're going to use those two numbers to write our domain. Our domain has to be in between those two yellow lines. Those are all the x values are in between those lines. So let's start with interval notation, because you guys seem a little bit like less freaked out by interval notation. Since I have a closed endpoint, do you guys remember, will I use a parenthesis or a square bracket on the -3 here? A square bracket. So I'm going to put a square bracket, -3. Now we always put the small number first. The -3 is our smallest value. And then I put a comma, and I put the maximum x value, which is 6. It also has a closed dot, so how do I finish this off? Square bracket. That's writing your domain in interval notation. Now that set builder notation looks funky, but you're going to start with a curly bracket every time for set builder. What letter am I dealing with for domain? X's. So you put an X first, and then a bar. That's always in your set builder notation. X bar. X such that. Right? Our domain is saying we have all the X's such that. Well, we need to write a sentence or an inequality in math that says all the X's in between those two numbers. Okay? So here's how we would do it. We're going to kind of turn this interval into an inequality. We're going to say -3. Now, if it's a closed dot, would I use a less than or a less than or equal to? Less than or equal to x is less than or equal to 6. And then close your curly bracket. So you're going to write a compound or a regular inequality, depending on the scenario. Because that says, here again, I'll say it again. All the x's such that, or when, x is in between -3 and 6. That's what the inequality says. That's what your domain says here. All these x's in between those two yellow lines. Okay? Is that okay so far? All right, let's try the range. So in range, I'll change my color. Let's use green. So we need our highest y value. So the highest up you go, and the lowest down you go. Where is that maximum y value? Is that 4? Yep. 4. And where is our minimum y value? Yep, -5. Okay. Now, when you write your interval, we'll start again with interval notation here. When you write your interval notation, do you start with the 4 or do you start with the -5? You start with the negative. You start from the bottom. So domain is left to right, range is bottom to top. So here, will I put a bracket or a parenthesis with the -5? A bracket. -5, comma. I want the y's from here up to 4. And at 4, there's a closed dot, so I put a bracket. Now your set notation is similar to what we did for domain. We have a curly bracket, but this time for range, what letter do I need to put there? Y's. All the y's such that, or where, or when, whatever you want to say, the y's are in between -5 and 4. So what compound inequality will I put in the middle? -4, -5, yep. Less than or equal to y for range, is less than or equal to 4. Okay, they say the same thing and has different notation. The notation, you're not going to always have to write both of them. I want to teach you both, and then there are certain cases where it makes more sense to do one notation versus the other. Okay, so let's flip our paper over. Let's spend a little bit more time here with this notation. So now we have a multiple choice question. It says the function f of x squared minus 2x minus 3. That's this parabola that is graphed, f of x. We want to know multiple choice which one is the domain and range in interval notation. Well, the first thing I want to point out to you before we do this is what's on the end of your graph here? Endpoints or arrows? It's arrows. They're kind of hard to see. They're kind of small, but there are arrows on the end of your graph. Now, I know you'll know this, and I want you to say, what do the arrows mean? It goes forever. Goes left forever, right, up, down, whatever, whichever way the arrows are facing. So let's talk about domain. All right, domain's easiest, left to right. If I have an arrow on the left, where does my domain go to the left? It's going forever that way. -infinity is to the left, forever. And then if my arrow on the right is going forever, where does it go in the positive direction? Towards infinity. So do you see a domain that says I go from -infinity to positive infinity? C. Yeah. So C right here. Now, that's the only one, so let's make sure the range at least makes sense. The range says you start from -4, which is right here, and you go up to infinity. Does this graph go up forever? Yes. All right. So one thing I want to point out before we move on. What kind of symbol with the interval notation is always seeming to be with the infinities? Like, do you see any brackets with the infinities here? No. You always, maybe make a note to yourself, or at least a mental note, always use the parentheses for infinity. Never, ever use a square bracket. Numbers, give and take. Infinity, because infinity is not a number. Infinity is a concept of going on forever. So you can't actually reach infinity, because infinity, again, is not a number. So you put a parenthesis there, because it just keeps going. There's no solid end place. Whereas on this graph, you actually have an end place at -4. You can't go past -4, but you never actually end up going up. Does that make sense? Yes? Yeah, infinity is not a number. I was teaching Sunday school one time, and it was like a preschool class, and this 4-year-old told me that she was going to count to infinity. So, of course, being a math person, I was like, you can't count to infinity, which really went over well with a 4-year-old, but she decided she was going to try to count to infinity, so the whole hour she was just counting and counting and counting. But yeah, she tried. She was never going to get there. I don't remember. It was never years ago. But there is another weird, I'm sure this is true, but you will never be able to count to 1 billion. Because in your lifetime, there's just literally not enough time for you to sit and count 1, 2, 3, all the way up to 1 billion. That's how big it is. So you can try, you won't get there. Yeah, I do.
I have $1 billion.
For $1 billion, I'll take that.
How do they count money?
How do they count money? Very carefully. I don't know. I don't know if anyone actually has $1 billion bills in their hand though to hand to someone. I don't know if they would actually do that. Really? Yeah. You can count to $1 million. All right. For problems like what we just did, I just want to remind you to always look for arrows on the graph. All right. The arrows. If there's an arrow, there will be an infinity somewhere in your domain or your range. When you look at domain and range on a graph, these are just reminders, but they're important because there's always going to be someone who makes this mistake. Domain is read from left to right. Okay? Domain is the x's, so it is along the x-axis. It's left and right. Range is read from bottom to top. Smallest to biggest. Bottom to top. Along the y-axis. And finally, domain and range are always written from small to large. Okay, the small number to the bigger. They'll put the bigger number first. All right, let's finish up with a couple domain and range from a graph. We'll practice some different notation here. They want us to practice both interval and set builder notation. The interval will be really easy, right? I think interval is easier for graphs. Domain, again, is our x's. So what is the farthest to the left x on the circle? -1. We'll get a bracket or a parenthesis. Bracket at -1. And how far to the right does this graph go? 5, comma 5. And that gets another bracket because we're ended there. Now, if I wanted to do this in set builder notation, I get a curly bracket. I put my x, and what comes after the x? That's such that bar. And what compound inequality would you write? -1, less than or equal to x, less than or equal to 5. Right, that would be your set notation for domain. Now your range goes bottom to top. So let's do interval first. Where's the lowest y value? -3. That gets a square bracket again because there's like no open circle at the point right there. How high up does your range go? 3, comma 3. I want to give you a second. I want you to try to write that set notation by yourself, and then you can check on the board here when you're done to see if you wrote it correctly. See if you can make sure you have the right letter. That's the first thing. What letter should you have? Y's. Make sure you use the right inequality symbol. Curly brackets and such. Good so far? All right. The next one is a line. It's a little hard to see on your paper the way it was copied, but if you need to, the dot on the left is an open dot. The dot on the right is a closed dot. So if you need to darken those in, you can do that. Let's start with our domain and interval notation. When I have an open dot, what kind of symbol am I going to use in my interval? A parenthesis. There's no infinity because it's not an arrow, it's just an open dot. So we get the parenthesis. What x is that at? -5, yeah. Then we comma. How far to the right does my x's go? 4. What symbol does that get after the 4? A bracket. Now, if you're going to do your set notation here, you start off the same way. Curly bracket, an x, a bar. All the x's such that. Now, your inequality, you just need to be careful with the symbol. You start with that -5. But what inequality comes after -5 this time? Just less than, not the equal to, because it's an open dot. X is less than or equal to 4. Very good. That will be your domain written like that. All right, now our range is going to be similar. Where's our lowest y value up here? -2. What kind of parenthesis or bracket does it get? Parenthesis, because it's an open dot at the bottom. So parenthesis, -2. How high up does it go? 3. Just like the last one, I want you to write the set notation on your own, and then check up here on the board. Okay, make sure you use the right letter, the right symbol. You have your curly brackets and your such that part. Good? All right. Let's try the next one. Oh, what do I see on graph 3? What's on the ends? Arrows. All right. The arrows are going to change a couple things up here. Starting with our domain. Interval notation. How far left do we get? -4. That could say bracket. -4. I forgot the negative. Now, how far right do you go? To infinity. So comma infinity with a parenthesis. Now, when we do set notation this time, you start with your curly bracket, x such that. Now, there's a couple ways to write this. Can anyone think of an inequality that you can write that says all the x's bigger than -4? Do I have to do, so I'll show you one. Here's one way you can do it. You could do -4 less than or equal to x is less than infinity. But, I mean, while it's acceptable, it's not really formal math right there to do an inequality with infinity. Can you guys think of a way that I could write the inequality that doesn't have that infinity there? Yeah, x such that x is greater than or equal to -4. Now, if you wrote the compound inequality with infinity, that's fine. It really is. Like, I'm not going to take off points or anything, but it's not formal math. Formal math, we would just say all the x's bigger than or equal to -4. Now, same thing with the range, but this one's going to look a little different. Where's my arrow going down to? -infinity. Where's the arrow going up to? Positive infinity. Do you guys remember another way to say -infinity to infinity?
Y.
Well, all kind of, but like it's a phrase. All real numbers. Have you heard that before?
Yeah.
So if I have all the negatives and all the positives, that's all real numbers. So here's how we do that mathematically in set notation. You're going to learn another math symbol here. You're going to write the y such that all the y's. Now there's a little Greek letter called epsilon. It kind of looks like a claw, right? That means in, all the y's are in, that's another math symbol word, in the set of real numbers. So you could either write out real numbers, or in the reals, or if you want to be really mathematical about it, they write a bold-faced R. So there's 2 lines on the side, and then an R. What the heck even is this? Set notation. Right. But again, that in the R, like in R just means in the set of real numbers. In the real. Alright, so I want you to try the last one. We can go over tomorrow. I want you to try that back page. There's a little bit of homework. The back has all the answers on it. So check as you go. We'll go over this before we start tomorrow. Okay? Good work. I know there's some funky stuff. We will continue.